Functional groups. What is a functional group? Organic compounds fall into organic families which contain certain combinations of atoms in the molecules. These different categories are called functional groups. A functional group is defined as a particular combination of atoms that contributes to the physical and chemical characteristics of a substance. The four common function groups are the carbon-to-carbon double bond, the hydroxyl group, which is bond OH, the amine group, which is bond N, and the carbonyl group, which is a C double bonded to an O. One main type of functional group is the double or triple bond between carbon atoms. A saturated bond in an organic compound is when a carbon atom is single bonded to another carbon atom such that a strong covalent bond makes it difficult to break. So when all the carbon atoms are joined by single bonds, they are very unreactive because there's no place to add additional atoms. Unsaturated bonds, however, occur in double or triple bonded carbon atoms, and they become more reactive. The second and third bonds are not as strong as the first bond, and therefore are easily broken. Hydrocarbons with double or triple bonds are therefore more reactive. The carbon bonded to oxygen or nitrogen by a single bond. Another type of functional group is a carbon atom bonded to a more electronegative atom. Oxygen, nitrogen, and the halogens are more electronegative than carbon. This means that polar bonding is occurring. Polar bonding increases the strength of the intermolecular forces between the molecules. More force is required then to separate the molecules, resulting in higher boiling and melting points. The presence of an OH and or an NH group enables an organic molecule to form hydrogen bonds with other such groups. This means intermolecular forces increase and organic molecules can more readily mix with polar molecules and dissolve more readily in other polar molecules. Now, here is a table that shows the electronegativities of common elements. H is 2.1, C 2.5, N 3.0, and O at 3.5. So this will help us understand our bonding. And here are some structures that we were talking about in the previous slide. Take a moment. A hydrogen bond forms between an electronegative NO or F atom of one molecule and the more positively charged H atom of an adjacent molecule. Now, carbon bonded to oxygen by a double bond. A third type of functional group consists of a carbon atom double bonded to an oxygen atom. This double covalent bond between carbon and oxygen means that 4 electrons are shared between the atoms. This makes the carbon to oxygen molecules strongly polar covalent. C double bond O groups have higher melting and boiling points than other compounds. C double bond O have an increased solubility in polar solvents. Now, let's talk about the alkyl groups. An alkyl group is a substitution group or brand that is derived from a hydrocarbon. The general name used for these is R. Alkyl groups are branches off the main chain. Now, this table provides us with some common functional groups. It shows the type of compound, the suffix, a diagram showing the functional group, and some examples. This table provides you with the common functional groups. Have this available as you work through this module. Now, here is an example of an alcohol and ether. This is a molecular model for methanol. An alcohol is an organic compound that is characterized by a hydroxyl functional group with the general formula ROH. If we take a closer look at this is methanol. The R represents methane, which is the main chain, CH3. You have 3 H atoms and 1 carbon atom, shown in black. We're bonding that to our OH. So we now have 1 O atom, shown in orange, and 1 H atom, shown in white, attached to the orange. So that's a molecular model for methanol. Now, we've shown you now an alcohol is like water, HOH, but one H is replaced by the alkyl group. An alkyl group is a hydrocarbon group derived from the alkane. And we can see that ether is water with both H atoms replaced. So we have ROR, and that's the general formula. Alcohol has 1, so it's ROH. Some alcohols, methanol, is very highly toxic, can cause blindness and death in even small amounts. Ethanol is also a depressant and can be poisonous. 2-propanol is the term for rubbing alcohol. How to name alcohols? The functional group OH is called the hydroxyl group. The IUPAC, the alcohol for alcohol names, consists of 3 parts. First part of the name tells the number of carbons in the longest carbon chain. The second part, AN, tells that the hydrocarbon chain is saturated. The last part of the name, OL, refers to the hydroxyl group. If the name of the alcohol begins with a number N, then the hydroxyl group is attached on the nth carbon atom in the chain. So here's a sample problem. Draw the structural formula and write the formula for 1-butanol. So we're going to draw the carbon backbone or the main chain. But means 4, so we are going to draw 4 carbons. Then we're going to add the OH group in the appropriate position. The ANOL tells you that there is an OH group. The number 1 tells you that the OH group is attached to carbon 1. Add OH to the first carbon or the last carbon, which then can become the first carbon. our 4 carbons, and we then complete the remaining bonds with the hydrogen atoms. So we're going to get our 4 carbons, and we start numbering them from the side closest to the OH. The OH is on the first carbon, but it's on the right side, and that's fine. And then we've attached the other H's. So we have 3 CH3, CH2, CH2. Then we have one more CH2 with a OH. And then it's 1 butanol. The structural formula can also be written as a condensed structural formula, as shown in the square brackets. Now, let's continue to draw the structural formula and write the formula for 2-pentanol. Draw the carbon backbone. The prefix but tells you that there are 4 carbon atoms with no multiple bonds. Add the OH group in the appropriate position. The name 2-pentanol means the OH group is attached to the second carbon atom. Sample problem, draw the structural formula and write the formula for 2-pentanol. Complete the remaining bonds with the H atoms. We now have our structural and our name and our molecular formula. The condensed structural formula shows the attached OH group in brackets immediately after the C to which it is attached. Now, this is for you to try. Write the name of the alcohol that has the condensed structural formula CH3, CH2, CHOH, CH3. Check if you're right with the example at the bottom. Now, it's your turn.